The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So eventually today we're going to go on and finish up section 10.2. We'll look at part 2 of that. But first we have some questions. And so let's see here. Let me change the viewing window. Okay, Gabriel, this is the assignment you're talking about. Do you know which one it is you wanted to look at?
Go up. Oh, this one, that 23.
23. Okay, let's take a look at 23. Solve the equation, approximate the solutions to the nearest hundredth. Okay, so this is what, 10.2 part 1, number 23. So it says let g of x equal 4.5x squared plus 0.4x. For what value or values of x is g of x equal to 3.15? Okay, so let's go back to the whiteboard screen. So first of all, we're going to substitute 3.15 in the place of g of x. So our equation would look like this. We'd have 3.15 equals 4.5x squared plus 0.4x. Okay. So we want to solve that equation. Well, there are decimals. And in fact, if we want to get rid of all the decimals, we'd have to multiply both sides by 100. Because over here we need to move it 2 places. So we'll multiply the left side of the equation by 100 and the right side of the equation by 100, distributing 100 times 3.15 would be 315. 100 times 4.5 would be 450x squared. 100 times 0.4x would be 40x. So far, so good? Okay. I'm going to subtract 315 from both sides. So I get 0 equals 450x squared plus 40x minus 315. Oh, I can see that every one of these terms, 450, 40, and 315, is divisible by 5. I don't have to do this, but I can reduce it down ahead of time. So I'm going to divide each term by 5. I get 0 equals, let's see, 450 divided by 5 would be 90x squared. 40 divided by 5 would be 8x minus, let's see, 315 is 63. Okay, let me write that a little more legibly. So now I've got my equation. It's in standard form. There's no decimals. I've reduced it down. Unless I've made some mistakes, I'm ready to go. So A is 90, B is 8, and C is negative 63. So X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 8 plus or minus the square root of 64. Let's see, we've got minus 4 or negative 4 times 90, which is negative 360 times negative 63. We get a positive 22,680 all over 2 times 90, which is 180. Okay. x equals -8 plus or minus the square root of 22,680 plus 64 is 22,744 all over 180. Okay, now directions say, let's see, approximate the solutions to the nearest hundredth, enter your answers as a comma separated list. All right, so the fact that it's saying approximate solutions to the nearest hundred tells me that probably 22,744 is not a perfect square, but I'm going to try it anyway. I'm going to take the square root of that. And that's correct. It's not a perfect square. Okay, too bad. So now let's take this and go to the next page. X equals -8 plus or minus the square root of 22,744. 22,744 divided by, I think it was 180. Okay. So we're going to get x equals -8 plus the square root of 22,744 all over 180. X equals -8 minus the square root of 22,744 all over 180. But we are to find decimal approximations. Now, could I simplify the radical 22,744? Sure, probably finish about lunchtime. But I don't need to do that because they just want that final decimal answer. Okay. So let's take a look at the first one, parentheses, -8 plus the square root of 22,744, close up the radical, close up the entire thing, divided by 180, and we get 0.79339, etc. Rounding to the nearest hundredth, that would be there. The 3 would round down, so we're going to get 0.79. And again, what I put into my calculator was parentheses -8 plus, and then this whole thing, 22,744. But let's see, again, we've got this extra set of parentheses there, and then divided by 180. Okay, then I'm going to do the same thing, except instead of a plus, it's going to be a minus. And I get -0.882284, etc. Here's the hundredth place, the 2 would round down. So our two answers, 0.79 and -0.88. Does that take care of that one for you?
Yeah.
All right. Any other questions, anybody? Well, I've got the WebAssign open. All right, then we'll go ahead on to the next section. And I want to start with a problem. Can you see my whiteboard screen okay? Somebody?
Yep.
Yep, okay, thank you, thank you. All right, it says, refer to the illustration, which I've got drawn here. Instead of using the Main Street and First Avenue crosswalks, let's see, to get from Nordstrom to Best Buy, a shopper uses the diagonal crosswalk to walk 97 feet directly from one corner to the other. So instead of doing this, followed by that, they do this, okay? And it uses the diagonal crosswalk to walk 97 feet directly from one corner to the other. So this is 97 feet, the diagonal crosswalk, okay? If the length of the Main Street crosswalk is 7 feet longer than the First Avenue crosswalk, so the Main Street crosswalk, that's this one, is 7 feet longer than this one. So let's call this X, and this would be X plus 7, okay? How much walking does the shopper save by using the diagonal crosswalk? All right, so what we've got here, assuming that the city did their streets perpendicular and all that good stuff, we've got a right triangle here. Let's see, here, here, and here. okay? We need to find the lengths of the two sides that aren't already labeled. We know the long side is 97 feet. We need the length of the other two sides. So what we have here is a right triangle. And there's a theorem called the Pythagorean Theorem that was supposedly, I guess, created by a guy named Pythagoras. At least that's the story. And it says this, okay? If the long side is called the hypotenuse, okay? The two shorter sides are called the legs of the triangle. The two shorter sides are labeled A and B, and the long side is labeled C. It doesn't matter which leg is A and which leg is B. But for a right triangle, the following situation is true. A squared plus B squared equals C squared. That's known as the Pythagorean theorem. We're going to use that to come up with the length of the two legs, okay? So what I'm going to do now is I'm going to transfer this triangle to the next page. So we've got 97 feet, x feet, and x plus 7 feet, okay? Using a squared plus b squared equals c squared. The long side is c, the other two sides are a and b. In fact, here, let's label those in red. So this is c, a, and b. So if a squared plus b squared equals c squared, we get the following equation. X plus 7, that's a, squared plus x, that's b, squared equals 97, that's c squared, okay? Going from there, x plus 7 times x plus 7 is x squared plus 7x plus 7x plus 49 plus b squared, or x squared, equals 97 squared. Let's see here. 97 squared is 9,409. Going on, combining like terms, we get 2x squared plus 14x plus 49 equals 9,409. Continuing, we'll subtract 9,409 from both sides of the equation, and we get 2x squared plus 14x. Let's see, if we take 49 minus 9,409, we get minus 9,360 equals 0. Okay, so here's our quadratic equation in standard form. Now, I notice that all the coefficients are even, so I could go through and divide each term by 2 just to make the numbers somewhat smaller. Let's see here, 9,360 divided by 2 is 4,680. Okay, so I've got my quadratic equation ready to go. And I think I'm going to go ahead and take this to the next, let's see, well, we'll go ahead. Let's see what we can do here. A is 1, B is 7, C is negative 4680. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 7 plus or minus the square root of 49. Then we've got minus 4 times 1, which is negative 4, times negative 4680, which is a positive 18,720 divided by 2. Okay, and I'm going to need to get some more room here. So let's take this and copy it. -7 plus or minus, let's see here. So x is -7 plus or minus all over. And let's see here. I got to make sure I'm getting the right information. 49 plus 18, 720 over 2. Okay. 49 plus 18, 720 all over 2. Okay, going on. I must apologize. The numbers in this section are rather large, but it's a good thing we can use a calculator. So x equals -7 plus or minus the square root of, let's see, 18,720 plus 49 is 18,769 over 2. Let's see if 18,769 is a perfect square. It is. Nice. So it's 137. So now I've got x equals -7 plus 137 over 2. X equals -7 minus 137 over 2. -7 plus 137 is 130 over 2 would be 65. -7, oops, this should not be a square root, okay. Minus 137 would be what? -144 over 2, which is -72. So x is 65, x is -72. Those are the two solutions to the quadratic formula. But now let's take those and let's go back to the actual problem. Let's see, 65. So we had x is 65, x is -72. X is a distance. And we're going to see this time and time again in this section that when we use the quadratic formula to solve a particular equation, we'll get two solutions. And if it's dealing with distance or length or width or time, we can't use negative answers because we can't have a negative distance, maybe in some science fiction movie, but not here. So the -72 doesn't fit the actual problem. So if x is 65, this is 65 feet. 65 plus 7 would be what? 72 feet, okay? Now the question says, how much walking does the shopper save by using the diagonal crosswalk? Well, this distance plus this distance, 72 plus 65, is 137 feet, okay? Using the diagonal crosswalk, 97 feet, 40 are left, or 40 is left. So how many feet do they save? 40 feet. So by walking the diagonal instead of the two other crosswalks together, they save 40 feet. All right. But the basis behind that whole thing was using this Pythagorean theorem to come up with the lengths of the three sides. Any questions about this example? All right, let's go on to another example then. This says, right triangles. The hypotenuse, that's the long side of a right triangle. Let's see, is 2.5 units long. So this is 2.5 units long. The longer leg is 1.7 units longer than the shorter leg. So the way I've got it drawn, this is the shorter leg. So the longer leg would be 1.7 units longer than the shorter leg. Find the lengths of the legs of the triangle. All right, any question about where I got all those labels? So this is C, this will be A, and this will be B. So using A squared plus B squared equals C squared, we get X squared plus X plus 1.7 squared equals 2.5 squared. And now it's the same process as before. X squared is X squared. X plus 1.7, the quantity squared, is X plus 1.7 times X plus 1.7. And 2.5 times 2.5 is 6.25. Let me double check that. 2.5 squared is 6.25. Okay. Now we've got x squared plus x squared plus 1.7x plus 1.7x plus, let's see, 1.7 times 1.7, I think that's 2.89. We'll find out. Yes, it is. 2.89 equals 6.25. All right, combining like terms, those go together, those go together. 2x squared plus 1.7 plus 1.7 is what? 3.4x plus 2.89 equals 6.25. Then we'll subtract 6.25 from both sides of the equation. 2x squared plus 3.4x. And then let's see, we've got 2.89 minus 6.25 is minus 3.36 equals 0. We're going to multiply both sides by 100. To get rid of the decimals, distributing, we get 200x squared plus 340x minus 336 equals 0. Well, I see that they're all even, so I can at least take out a 2. Actually, I can take out a 4. Let's do that. We'll divide by 4. 200 divided by 4, we get, let's see, we get 50x squared plus 340 divided by 4 is 85x minus 336 divided by 4 is 84 equals 0. Okay, so we've got our quadratic equation in standard form. We got rid of the decimals. We've reduced it down. So we're going to have A is 50, B is 85, C is negative 84. You know what? I'm going to just take this and go to the next page and start over. So we've got 50x squared plus 85x minus 84 equals 0. Okay. Now let's see if I can get it all on this one page. A is 50, B is 85, C is negative 84, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 85 plus or minus the square root of, let's see here, 85 squared is 7,225 minus 4 times 50. So let's see here, negative 4 times 50 is negative 200 times negative 84 is a plus 16,800 all over 2 times 50, which is 100. X equals negative 85 plus or minus 16,800 plus 7,225. Whoops. 225 is 24,025 all over 100. Now, let's see if 24,025 is a perfect square. Yes, it's 155 all over 100. So x is negative 85 plus 155 divided by 100, or negative 85 minus 155 divided by 100. Negative 85 plus 155 is 70 divided by 100 would be 7/10. Let's see. Since this original problem was in decimals, I think I'm going to write this as 0.7. Okay. Then we've got, let's see, negative 85 minus 155 is negative 240 divided by 100 would be negative 2.4. So x is 0.7, x is negative 2.4. However, once again, if we take these and go back to the original problem, 0.7 and negative 2.4, let's see. X is a length, so it can't be negative. So x has to be 0.7 units, and then 0.7 plus 1.4 would be 2.4 units. So the question of find the lengths of the legs, one leg equals 0.7 units. Let's see, other leg equals 2.4 units. And there we have that problem. Any questions there? I could say the numbers are humongous, but we have a calculator. All right. Now we've been dealing with triangles, right triangles. Here's a rectangle. It says the largest permanent movie screen is in the Panasonic IMAX theater in Darling Harbour, Sydney, Australia. Now, this may not be true now, but it was at the time. The rectangular screen, okay, so we're dealing with a rectangle, has an area of 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. Well, we'll call this the length and this the width. It's 20 feet longer than it is wide. So if the width is x, the length would be x plus 20. The length is being compared to the width. So if the width is x, the length is 20 feet more than that, 20 feet more than x, x plus 20. Okay, now the area of a rectangle is the length times the width. So we've got 11,349 equals x plus 20 times x. Continuing on, 11,349 equals x squared plus 20x. Subtract 11,349 from both sides of the equation. 0 equals x squared plus 20x minus 11,349. Okay. Let's see. I was looking to see if it said anything about decimals. It didn't, so hopefully things are going to come out nicely. So A is 1, B is 20, and C is negative 11,349. Well, you wouldn't think it would come out with exact or nice numbers. We'll see. X is negative B plus or minus the square root of B squared minus 4AC all over 2A. X is negative 20 plus or minus the square root of, see, 20 squared is 400, minus 4 times 1 is negative 4, and then negative 4 times negative 11,349 is 45,396 all over 2. 45,396 plus 400 is 45,796 all over 2. And let's see if that's, if I can't talk. Let's see if 45,796 is a perfect square. The square root of it is 214. So x is negative 20 plus or minus 214 over 2. So x is negative 20 plus 214 all over 2. X is negative 20 minus 214 all over 2. So let's see here. Negative 20 plus 214 is 194 divided by 2 is 97. Negative 20 minus 214 is negative 234 over 2, which is negative 117. Okay, now, again, x is a distance, in this case, a width. So again, the negative doesn't work. So if the width is 97 feet, the length would be 97 plus 20, which is 117 feet. And it says, find the dimensions. So the length is 117 feet, the width is 97 feet. How would you like to have that in your television room? Okay, let's see here. All right, we're going to look at another one that's going to involve some fancy drawing on my part, so I'll see what I can do with it. Okay. What else do we know? We know, let's see, this to here is 5 inches. And this to here is 4 inches. And let's see here. We've got some lovely trees and some water. And there's a sailboat out here on the water. Yes, I know. I'm such a great artist, maybe a con artist. That's about it. All right. So here's what the picture says. It says, the matting around the picture has a uniform width. Okay, so the picture is the trees and the lake and the sailboat, and then the matting is that let's see here. This stuff here, that's the matting, okay? So here we'll make it yellow. It says, where did it go? The matting around the picture has a uniform width. So basically this distance right here is the same as this distance, is the same as this distance, is the same as this distance, okay? The matting or the frame around the picture is uniform width. How wide is the matting if its area, so the area of the matting, equals the area of the picture, round to the nearest hundredth of an inch, which tells us that when we get down to the end, our quadratic formula isn't going to come out nice. All right, now, let's consider just the picture. We know that this distance from here to here is 5 inches, and this distance from here to here is 4 inches. So the picture, the area is 20 square inches, okay? 5 times 4. It says the matting around the picture has a uniform width. How wide is the matting if its area equals the area of the picture? So the area of the matting is also 20 square inches, okay? So the frame, the matting area is equal to the picture's area, okay? So the total area would be 20 plus 20 is 40 square inches, all right? Now, we know that the matting has uniform width. So let's call, let's see here, let's call this distance x and this distance x, okay? So that uniform width we're going to call x, all right? Now consider this. This distance, which we'll call the width of the entire thing, is 4 inches plus x, so it's 2x plus 4 inches. You see where I'm getting that 2x? There's an x distance here, an x distance here, and then that's 4 inches, okay? This distance is the 5 inches And then there's an X and an X, so 2X plus 5 inches. So the area of the whole thing equals the length times the width of the whole thing. The area of the whole thing is 40 square inches. The length is 2X plus 5, and the width is 2X plus 4. So now we've got a quadratic or second degree equation. But again, I want to stop there and go back. Do you have any questions about where I got any of those values? Okay. 40 equals 4x squared plus 8x plus 10x plus 20. 40 equals 4x squared plus 18x plus 20. We will subtract 40 from both sides. 0 equals 4x squared plus 18x minus 20. We can divide everybody by 2. 0 equals 2x squared plus 9x minus 10. Okay, I'm going to take that and go to the next page. 0 equals 2x squared plus 9x minus 10. Okay, so now A is 2, B is 9, and C is negative 10. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 9 plus or minus the square root of 81. Minus 4 times 2 is minus 8 times minus 10 is plus 80 all over 4. X equals negative 9 plus or minus the square root of 161 all over 4. Let's see, 161 square root is not nice. So X equals negative 9 plus the square root of 161 all over 4. X equals negative 9 minus the square root of 161 all over 4. And let's see here. So parentheses negative 9 plus the square root of 161, close that up, close the whole thing up, divided by 4. And I get 0.922144. And it said round to the nearest hundredth of an inch. So that would be here. The 2 would round down. Okay. And then the second one. That's negative 5. Well, I can stop there because again, we're dealing with a distance, so it can't be negative. So X is approximately 0.92 inches, and that's the width of the uniform border, the matting around the picture. Okay, let's see here. I think I've tortured you enough today. So over the weekend, finish up section 10.2, part 2. That is, finish up section 10.2 by doing part 2. I will be back at 1:15 with an office hour. If you have any questions? Otherwise, have a good weekend. Just looking forward, next week, Veterans Day, I believe, is on a Thursday. Let's see here. Yes. So there will be no classes or office hour on Thursday, but I'll remind you of that next week. All right, we'll stop the video.